गुड मॉर्निंग बच्चों। आज हम कुछ पीवाई क्यूज डिस्कस करेंगे बेस्ड ऑन द रेट ऑफ रिएक्शन। ओके, फर्स्ट वी व्हाट डू वी मीन बाय रेट ऑफ ए रिएक्शन? दिस इज नथिंग बट द रेट ऑफ चेंज ऑफ कंसंट्रेशन विद टाइम। इसको हम दो तरह से एक्सप्रेस कर सकते हैं, या तो एवरेज रेट ऑफ रिएक्शन या इंस्टेंटेनियस रेट ऑफ रिएक्शन। एवरेज रेट ऑफ रिएक्शन मीन्स चेंज इन कंसंट्रेशन इन ए पर्टिकुलर टाइम पीरियड डिवाइडेड बाई दैट टाइम पीरियड। और इंस्टेंटेनियस रेट मीन्स दिस इज द rate of reaction at a particular instant. Okay, that means अगर हम एवरेज रेट लिखें तो एवरेज रेट हो जाएगा सपोज डेल्टा ऑफ ए अपॉन डेल्टा टी। सपोज ए इज द रिएक्टेंट, देन एवरेज रेट ऑफ रिएक्शन विल बी माइनस डेल्टा ए बाई डेल्टा टी। और जो इंस्टेंटेनियस रेट ऑफ रिएक्शन होगा दैट विल बी minus dA by dt. That is when delta t tends to 0, the rate becomes instantaneous rate. Okay. अब हम मान लीजिए इस रिएक्शन का रेट हमें लिखना है, a plus 2b gives 3c. Then rate of this reaction is written as minus 1 upon 1, that is stoichiometric coefficient of a is 1. So minus dA by dt equal to minus 1 upon 2, where 2 is the stoichiometric coefficient of B. So minus 1 by 2 dB by dt equal to 1 by 3 dC by dt. Now why we have put the minus sign in case of reactants? Because we know that the reactant concentration will decrease with time. So to make the rate of reaction positive, we have put negative signs for the reactants, and we have put positive sign for the product because product concentration will increase with time. So this is how the rate of reaction is expressed. Okay, now what do you mean by rate of disappearance? Rate of disappearance is nothing but the rate of consumption of A, we can say, because A is getting consumed in the reaction. A is the reactant whose concentration will go on decreasing. That means it will go on disappearing from the reaction mixture. So we say rate of disappearance of A is equal to minus dA by dt, rate of disappearance of B equal to minus dB by dt, and rate of appearance of C equal to dC by dt. That is how the concentration of C is changing with time. Okay, so this is how we express the rate of disappearance, rate of appearance. Rate of appearance can also be called the rate of formation of C. Okay, so that is how we can express the rate of a given reaction. Now we will take some examples to make this concept clear. We will take the past year board questions. Two board questions are there. This was asked in 2020 board exam. This is a reaction is given to us, A plus 3B gives 2C, and the reaction, the rate of formation of C, that is nothing but dC by dt. It is given to us as 2.5 into 10 to the power minus 4. What will be the rate? Rate will be moles per liter per second. That is the unit of rate. Now we have to find out rate of reaction, then we have to find out rate of disappearance of B. So these are the things to be find out. Rate of disappearance of B. Okay, so first we will write the rate of reaction. What is the rate of reaction? We can write as minus dA by dt is equal to minus 1 upon 3 dB by dt is equal to 1 upon 2 dC by dt. That is the rate of formation of C. Now we are given the value of dC by dt, that is the rate of formation of C is given to us. So what will be the rate? Rate will be nothing but 1 by 2 into dc divided by dt. Okay, as per this rate of reaction equation, rate is equal to 1 by 2 dc by dt, and dc by dt is given to us as 2.5 into 10 to the power minus 4. So the answer will be 1.25 into 10 to the power minus 4 moles per liter second. Okay, so we have solved the first part. Now the second part, we have to find the rate of disappearance of B. Okay, so we will write the same equation, that is minus dA by dt equal to minus 1 upon 3 dB upon dt is equal to 1 upon 2 dc upon dt. That is the rate of reaction. Okay, now we have to find out rate of disappearance of B, that is minus dB upon dt. This we have to find out, that is the rate of disappearance of B, and this will be nothing but, from these two we can say minus dB by dt is nothing but 3 by 2 into dc by dt. Okay, and dc by dt is given to us, so this will be 3 by 2 into 2.5 into 10 to the power minus 4, and this will be coming 3.75 into 10 to the power minus 4 moles per liter second. So that is the answer. So that is how we can find out the rate of disappearance or rate of appearance by writing the equation of rate of reaction. Now let us take one more question. This was also asked in the board exam of 2018. It says, for the reaction 2N2O5 gas gives 4NO2 gas plus O2 gas. This is the reaction given to us. The rate of formation of NO2 is, we are given the rate of formation of NO2, that is dNO2 upon dt. That is the rate of formation of NO2. It is given as 2.8 into 10 to the power minus 3 moles per liter second. Okay, and we have to find the rate of disappearance of N2O5. What we have to find out? Rate of disappearance of N2O5. This is the rate of disappearance of N2O5. Okay, so we will write the rate expression, or rate equation, that is minus 1 by 2 dN2O5 divided by dt is equal to 1 by 4 dNO2 divided by dt. This is the rate of reaction. So what we have to find out? Minus dN2O5 upon dt, that will be nothing but 2 by 4 into dNO2 by dt, that is half of dNO2 by dt is given to us, that is 2.8 into 10 to the power minus 3. So the answer will be 1.4 into 10 to the power minus 3, that is moles per liter per second. So this is the rate of disappearance of N2O5. Now we take two PYQs of IIT JEE. Then we will wind up this session. The first question is, This was asked in 2019 main. It says NO2 required for a reaction. NO2 required for a reaction is produced by decomposition of N2O5. Decomposition of N2O5 in CCl4 as per the equation is given to us, that is 2N2O5 gas gives 4NO2 gas plus O2 gas. That is same equation which we have written earlier. The initial concentration of N2O5, initial concentration is given of N2O5 gas is 3 mole per liter, 3 moles per liter, and it is 2 points after 30 minutes. After 30 minutes, the concentration of N2O5 is 2.75 moles per liter. Okay, so we have been given two concentrations. One is the initial concentration, another is the final concentration after 30 minutes. And what we have to find out is the rate of formation of NO2. Rate of formation of NO2 gas is to be found out. So how we will do? This is nothing but the average rate of reaction which is given to us. This average, because in 30 minutes concentration changes from 3 moles per liter to 2.75 moles per liter in 30 minutes. So this is the, we can say, rate of disappearance of N2O5. Okay, this is nothing but rate of disappearance of N2O5. That is nothing but minus, this we call as delta N2O5 upon delta T. This is given to us. Okay, and this will be 0.25 divided by 30. Okay, so this much moles per liter per second. This is the rate of disappearance of N2O5. And what we have to find out is the rate of formation of NO2 gas. So rate of formation of NO2 gas is nothing but delta NO2 gas upon delta T. This we have to find out. Okay, so we will write the rate of reaction for this, that is minus 1 by 2 delta N2O5 upon delta T, that is equal to 1 by 4 delta NO2 gas upon delta T. Okay, now minus this is given to us, this we have just found out. So what will be the delta NO2 upon delta T? That will be equal to minus 4 by 2 into this. So it will be minus 4 by 2 into delta N2O5 by delta T, which is nothing but, and minus minus is, it will become plus, so into 0.25 divided by 30. So this much moles per liter per second, that will be our answer. So that is how we can find out the rate of appearance or rate of disappearance. I will take one last question, then we will finish this session. The last question is, this was asked in 2019 main. It says, in the following reaction, XA gives YB log 10 base minus dA upon dt is equal to log 10 base dB by dt. Because A is the reactant and B is the product, so it is written minus dA by dt for A and plus dB by dt for product. Okay, and we have to find and plus 0.3010, that is given to us, and we have to find out that A and B can be represented by 4 options are given to us: N-butane and isobutane, N-butane and isobutane, that is A and B. Then C2H2 and C6H6, then C2H4 and C4H8, and D is N2O4 and NO2. So we have to find out the correct option among the 4 options. Okay, so what we can do, we can write this equation as log of 10 base minus dA by dt is equal to, we know that 0.301 is nothing but the value of log 10 base 2. Okay, this is log 10 base 2, and log A plus log B equal to log A into B. So we can write log 10 base 2 into dB by dt. Okay, now log is cancelled out from both sides, so we get minus dA by dt is equal to 2 times dB by dt, and this we can write as, if I take 2 here, so minus 1 by 2 dA by dt equal to dB by dt, and this is nothing but the rate of reaction for a reaction 2A equal to B. If I write this equation, this is the reaction, then its rate will be given by minus 1 by 2 dA by dt equal to dB by dt. So we can say that 2A gives B. Okay, this is possible only in C option, because 2 of C2H4 can give C4H8. So we can say the C option is correct. Okay, that is how we can find out the relation between rate of appearance, rate of disappearance, and rate of reaction. This is how we conclude our session, and I wish you all the best. Go on preparing for your exams. Thank you.